record it to my YouTube channel. And so go ahead and get this started here. So number 8 says a patient is ordered dopamine infusion to begin at 5 micrograms per kilogram per minute. The patient weighs 70 kilograms and the dopamine available is 400 milligrams per 250 ml. At what rate should the nurse begin the infusion? So when we talk about an infusion rate, just know that most likely, now this is a little bit of an assumption because it doesn't say specifically what they want, but because this isn't a drop, there's no drop rates listed anywhere, we're going to go ahead and assume that what we're calculating is an infusion rate at milliliters per hour, okay? So the question is, what is the volume per hour? What is the milliliters per hour? And we can confirm that with the answer to the practice test. So it says to begin the dopamine infusion at 5 micrograms per kilogram per minute and that the patient weighs 70 kilograms. So always with these weight-based questions, account for the patient's weight. So 70 kilograms times the 5 micrograms kilogram minute. And then what you're going to get is 70 times 5 is 350 micrograms. And that's per minute. Okay. So I think hopefully we're all on the same page as far as that's concerned. The next thing it says is that dopamine's available is 400 milligrams per 250 ml. So I'm just going to write this down here. So 400 milligrams per 250 ml. So the first issue we have, other than how do we solve this question, is that we have micrograms and then we have milligrams. So we need them both to be the same. We either need them both to be milligrams or we need them both to be micrograms. So since this is listed up here and I've already started working on here, I'm just going to go ahead and convert the micrograms to milligrams up here. And all I need to do is divide by 1,000. But if it's helpful, I'll show you my work. 1,000 micrograms, 1 milligram. And then we would get 0.35 milligrams per minute. Now, I know we don't want the minute part. We'll get to that and we'll address that a little bit later, okay? Now, the next thing is when I'm calculating an infusion rate, really what I need to be able to do is go from milligrams per minute, which technically is a rate, to the milliliters per minute. And I just need a way to get there. And then this 400 milligrams and 250 milliliters helps me get there. So I'm going to take my 0.35 milligrams per minute. Don't forget that's there. And I'm going to multiply by my, I don't want milligrams, I want milliliters. So I'm going to put my 400 down here and my 250 up here. And then I know I'm doing this right because I can eliminate the things that I don't want and I can keep the things that I do want. Okay. Again, I know we want this to be hours, but we're getting there. So I'm going to take the 250 times 0.35. I'm going to get 87.5, and I'm going to divide that by 400. And I'm going to get some funky number here, 0.21875, and that's milliliters per minute. Now, what I'm going to do next should help get rid of that funky decimal. I need to convert minutes to hours. So I'm going to multiply by 60 to get to, hopefully, the answer I'm looking for. So times 60, and I get 13.125 milliliters. I didn't give myself enough room. So milliliters per hour. Okay. Now, it says, at what rate should we start the infusion? So I wanted to check the key, but the way I would answer this is I would say it's 13.1 milliliters per hour. But let me double check. So the key left it completely there as 13.125. But since you're being asked to round things to the nearest tenth, I think you'd be okay with doing 13.1 milliliters per hour, but I would just verify that with your lab instructor, like how they want you to write answers that have a decimal ending. But my guess is that you would have a, that they would want it to be rounded up to the nearest tenth when it's a number greater than 1. Did that help answer like 8? I know that some of you, whoever asked, you know, I don't know if that's helpful for you or where you were. Okay, good. All right. Any other questions from this packet? Now I have the same packet you have, so you just tell me the number and you just put the number into the chat and I'll get it for you. You can just ask whatever's convenient.
Could you do a number 11?
I can.
Like I could figure out the math, but I think what confused me was the available was 100 milligrams. So I was dividing desired over had and then multiplying it by 30, which obviously was the wrong answer. So like, how would you know to kind of ignore that 100 mg?
Okay. So first of all, great question. And I know that that can be like a point of frustration is what do I keep and what do I know? So always, always, always what's important is what's ordered, right? So the ordered was 200 milligrams IV daily. It tells you what's available is 100 milligrams. So let's just say this was an oral drug that was just like a tablet or a capsule. If you had 100 milligrams available and 200 milligrams there, you would just give 2, right? So, but because it says 100 milligrams, which is true, it's probably the strength associated with it. But how is that 100 milligrams administered? Well, it has to be administered through some sort of concentration, and that's where the 30 milligrams per milliliter comes from. And so you would just ignore the 100 milligrams just because that's kind of like saying, if I told you, you know, take 2 Tylenol, you know, and then I told you that your available Tylenol was, you know, or I said, take 500 milligrams of Tylenol, your available is 250 milligrams. And then it's in, you know, there's 100 capsules. You don't really need to worry about the fact that there's 100 capsules, just like you don't really need to worry about that it's a 100 milligram IV. You just need to know, can you get to that 200 milligrams, which is why you ignore the 100 milligrams and you focus on the 30 milligrams per milliliter. The other reason is, how many milliliters are you going to administer? You can't calculate milliliters just knowing the you know, the strength of the drug. You need to know the concentration of the drug with the per milliliter. So that's just a roundabout way of saying that sometimes it's just a matter of looking at the question and just realizing that you don't need every piece of it every single time. And so, but the main thing is you don't need that 100 milligrams because it doesn't help you to answer the question. You need to know the order, which is 200 milligrams, and then you need to know the way to go from milligrams to milliliters, which is what the label tells you. If I had a picture, let me just see here if I have an example of like an image, just so you can kind of see how some of these look like. Yeah, a lot of times they're just listed as like volumes as opposed to the actual strength. So I'm not really seeing that there to give you a another scenario. So, okay.
That makes sense though. Thank you.
Okay, you're welcome. I don't know how much sense that made, but I appreciate you saying it did. 15 and then 21 and 22. You got it. All right, so 15. All right, it says calculate the number of hours and minutes that 420 cc's will run if infusing at 120 cc's per hour. Okay, so when we're doing this sort of question, one of the things that we have to do is we first know that we have apologize to get myself all organized. So 420 cc's. Make sure we're all looking at the same thing. So how many hours and minutes? 420 cc's if it's infusing at 120 cc's per hour. So I'm going to take what my my original or I'm going to take my total amount, the 420 cc's, and I'm going to calculate how much is going to go after I infuse it at 120 cc's per hour, meaning how much time will have passed or how much time will have passed by the time that bag is empty. So basically what I'm doing is I'm going from 420 to 0, and I want to know how long is it going to take to get to that point. So using my calculator, 420 divided by 120 will give me 3.5. Okay, so 3.5 what? Hours. So the time would then be 3 hours, 30 minutes. Does that make sense? For 15. Sometimes that question gets asked, if it started at this time, what time would it end? Sometimes, you know, you might get like 3.25. You just need to know that you need that 0.25 of an hour is 15 minutes, not 25 minutes. One way you can do that is if you write this as 3.5 hour, and then you want to know, like, I'm sorry, you already know that the 3 is an hour. So the 0.5 hour, 1 hour, 60 minutes. And that's how you can calculate how many minutes, just in case you get stuck and you don't know if you get some weird like decimal, like I said, 0.25 or 0.15 or 0.2. If you multiply that, whatever your decimal is, by 60, that'll tell you the minutes that you're trying to calculate. And then 15, yeah. All right, 21 and 22. All right, so 21 is just like that question that was asked previously. There's going to be extra information that we don't need in this problem. Okay, so it says Solumedrol 200 milligrams IV. It's received from the pharmacy in a 120 milliliter bag to infuse over 30 minutes with a drop factor of 10. No other IVs are running. What is the flow rate in drops per minute? So taking that, remember when we were calculating drop rate, you need to know 2 pieces of information. You need the flow rate and you need the drop factor. And that'll give you the drop rate, typically in drops per minute. Now, 21 says that you have a 120 milliliter bag infusing over 30 minutes. I have a drop factor of 10. And so when I do my calculation, I believe I get 40 drops per minute. Let me just double check. Yeah. 40 drops per minute. So again, you'll know that you've done this right because you're left with just what you were looking for, the drops per minute. So 40 drops per minute. Now, the other thing is, so you didn't use where it said, and this was very similar to the other question, it says you have Solumedrol 200 milligrams IV. It's like, it's just stating what type of Solumedrol it is. So let's say there was Solumedrol 100 milligrams, Solumedrol 200 milligrams, and Solumedrol 300 milligram IVs available. And then the way that that would be infused might just be different. So it's kind of like, is it the Cadillac? Is it the Mercedes? Is it the Porsche? What is, you know, the vehicle? And then, but when we're calculating flow rates, I just care about the rate. I just care about volume over time. I don't care about the strength of the thing. I mean, you care about that for the patient, obviously, but you don't care about it for calculating a flow rate. 22 is kind of a workup question to help you out with the heparin protocol. So it says heparin IV to infuse at 1,250 units per hour. The IV is 500 milliliters D5W with 25,000 units of heparin. What is it, the milliliters per hour? So let's do that one too. Let me just turn my paper upside down here. So when we're going from what this question is asking ultimately is we're going to go from units per hour to milliliters per hour. And this is exactly what you do in the heparin protocol. So like I said, it's kind of like a workup to the heparin protocol. So it says that we have 750. Which number am I doing? Yeah, 22. Oh, I read 23, but 22 is the same type of question. We have 750 units per hour. So I'm going to start with the flow rate. Okay. I don't want units. I want milliliters. And so the question says we have heparin IV to infuse at 750 units per hour. The solution is 25,000 units in a 1 liter bag of D5W. So 1 liter is equivalent to 1,000 milliliters. And then we said 25,000 units. We know we're doing this right because we've eliminated units. We're left with milliliters per hour. And when I do 750 times 1,000 and then divide it by 25,000, I get 30 milliliters per hour. So that was actually question 22. I know I read the question 23, but that was question 22. And then, oh, okay, 16 is another drop rate question that was asked here. So 16 says we have an IV of 500 milliliters infusing at 120 milliliters per hour. The drop factor is 15 drops per milliliter. What is the drop rate in drops per minute? So let's do that. So again, I don't care. I don't care the quantity of the bag. The only reason I would ever care about the quantity of the bag, meaning like the 500 milliliters, is if I wanted to know when that was going to run out. What I care about with, remember, when I'm calculating drop rate, I need two pieces of information. I need the flow rate and I need the drop factor. So what's my flow rate? My flow rate is 120 milliliters per hour. And my drop factor is 15. That's all I need to solve this problem. Anything else is just extra information. And sometimes that's how you know that you have extra information, is because you don't need it to solve what it is that you're trying to solve. So 120 times 15. Now, remember, when we answer this, the question says calculate the drop rate in drops per minute. So one of the shortcuts is get rid of hour and just make that 60 minutes. Okay, because they're the same thing, right? So it saves you a step. You don't have to do another conversion. So 120 times 15 over 60, and you'll get 30 drops per minute.
So the answer I got was like 30.875. And I'm just wondering, is it because it's drop rates, you don't round to like 30.1, like you always just round down?
No, so let me see if I can recreate. What did you plug into your calculator to get that answer?
It was like 120 times 15 equals 1,852.5 GTT divided by 60 minutes.
Okay, so well, I would just plug that into your calculator again, because it should only equal 1,800. 120 times 15 should just be 1,800.
Okay, I see.
Okay.
Thank you.
Yeah. So yeah, and drops always get rounded to the nearest whole drop, but as long as the department is still using the tests that I've created, the drops are always going to be to the whole drop. Like there shouldn't be any rounding issues. So as soon as you said like those numbers, I was like, something happened there.
But just so I know, like if it did happen to be like 30.6, you would round up to 31.
Correct. Yeah, someone said about 15 and 16. Actually, 15 and 16 are not the same question. So someone said they're asking the same question, just worded differently. No, 15 is asking you to calculate the number of hours and minutes that the infusion is running for. And then 16 is asking you to calculate the drop rate. So they are two different problems. Whereas so I worked out 15 up here, right? So 15 is asking how long will it take for 420 to go down to 0 if it's infusing at 120 cc's per hour, and then we got 3.5 hours. Whereas 16 is saying, I want to know if my flow rate is 120 milliliter per hour and my drop factor is 15, what is the drop rate? So they are two different questions.
I'm sorry, that was supposed to be 16 and 17, not 15 and 16.
Okay.
My bad.
That's okay. Yes, so 17 would be solved exactly the same way. So you have 180 milliliter over 1 hour or 60 minutes times 10, and you'll get the same answer. Or you'll set it up the exact same way we just did. Absolutely. The only difference is this is 180, this is 10. Okay. I'm getting some calls for the heparin protocol, so we'll go ahead and go through that. I think we scared someone away. All right. I just want to see. Okay. Yeah. So I'm going to display a different variation of the heparin. I mean, it's the same thing. It's just on one page instead of it being on mine. It's split in 2 pages. So put that up for you guys. Okay. So if you remember this from last semester, you probably remember that everything that's listed here from steps 1 all the way down to 15, that's all part of the protocol. So if you do a Google search for heparin protocol, you're going to see this listed. That's exactly what I did. Is I just did a copy paste and I got everything on there. You do not need to worry about filling in the CBC days, the GAIAC stool days, the neurochecks hours. You don't need to worry about doing those things. Those will just be filled in as part of the protocol for the actual what you're doing to the patient in a clinical setting. What we want to know is just answering the questions. Okay, so we're just doing the math and we're using the protocol to get to the math. So the first thing is you do need to know step 1. you need to convert the patient's weight, and this example is 110 pounds, to kilograms. Now on the test, if you remember last semester, I gave you a different patient weight, right? So you just need to convert pounds to kilograms regardless of what the pounds are. The next thing you need to know is step 2 tells you your IV bag, the 25,000 units heparin and 250 milliliters half normal saline, and then the bolus dosage strength, which is 1,000 units per milliliter. So as long as you know those two things, you know your bolus dose, or you know that you need those two pieces of information. The last thing on the initial parts 1 through 10 is number 10 restates what's listed up in the protocol. Bolus the patient with 80 units per kilogram, and then start a drip at 18 units per kilogram per hour. So it tells you how to start the heparin protocol. Okay. Then when you get down to 11 through 15, it's just a matter of isolating the APTT. Okay. So in the questions below, it says that after 6 hours, they had an APTT of 43 seconds. And so you just go to step 12 because step 12 has an APTT that fits in that range, right? And then you just do what it says to do in the chart. Now, these are the things that I can change on this test, on your test. I can change the patient's weight, and I can change what the APTT is. Now, likely I'm not going to change the APTT because this gives you two things to do: a rebolus and a change in the rate. Okay. The other ones only do one or the other and not both. So most likely you'll always be using step 12 in your actual exam. Now, with the patient's weight, the one thing I always like to note is that once you do like pounds to kilograms, if you get a number that's greater or that has decimals, round to the nearest tenth. Right after you do the patient's weight, go ahead and round to the nearest tenth. That way you get the same answers that I got, because that's what I did. I rounded to the nearest tenth after I calculated the patient's weight. The other thing is, on your test, you're only going to have 2 of the 4 questions, meaning you'll either only have A and B or C1 and C2. Okay. You're not going to have both. Okay. So that's at least something you don't have to worry about. So step 1 is we're going to convert the patient's weight from pounds to kilograms. So that's a 110-pound patient, divide by 2.2, and I'm going to get 50 kilograms. So the patient's weight is 50 kilograms. Now, I'm going to take that patient's weight and I'm going to follow the protocol. And it says initially, I want a bolus with 80 units per kilogram. And it even tells you up here, bolus patient with 80 units per kilogram body weight. So I'm going to take that 50 kilogram patient and I'm going to multiply by 80 units per kilogram. That gives me 4,000 units. Okay. Now, if it had just asked me to give the units for the bolus, we'd be done. But it says to give the milliliters of bolus. So looking at step 2 of the protocol, it says my bolus dosage strength is 1,000 units per milliliter. So what I'm going to do is I'm going to convert the units to milliliters. So 1,000 units per milliliter. And I use that information because we're calculating the bolus dose. So you're going to use the bolus dose information for calculating bolus dose, and then the IV drip or the heparin drip information for calculating the rate. So units, and then we have 4 milliliters, which is what we're looking for, right? Now, the shortcut to this is, regardless of what, the only thing that will change is the patient's weight. So I'm sorry, you can't see what I'm doing. The only thing that would change is the patient's weight. So it's 50 kilograms, right? So the only thing that would change is the patient's weight. So the shorthand of this is, I'm just going to take the patient's, I'm going to take the patient's weight times 80 and then divide by 1,000. That's how you would solve every single heparin protocol, part A for calculating the bolus dosage strength. You take the patient's weight. So this number 50 would change times 80 divided by 1,000. That will always give you the bolus dosage strength. Okay. So someone asked me in the third semester, what's the short, like nitty gritty of this? And that's really what it is. Okay. That's all, everything I wrote up there is what is written right here, 50 times 80 over 1,000. Okay. And like I said, if the patient weighs 65 kilograms, 65 times 80 divided by 1,000. If the patient weighs 48.5 kilograms times 80 divided by 1,000. That's how you would calculate the bolus dosage strength every single time for the initial bolus. All right. For the heparin IV drip, it says that we need to, I'm going back to this. It says to start the drip at 18 units per kilogram per hour. It also says that up here. So same patient, same weight, 18 units kilogram hour. We get 900 units per hour. Now, again, if I just wanted units per hour, I'd be done, but it doesn't want units per hour. We want milliliters per hour. So we're going to go back to our protocol. You're going to see that in step 2 of the protocol, it says heparin 25,000 units in 250 milliliters, half normal saline. That's just where that is. That's what they're hooked up to. That's what their IV is connected to. And so we're going to use that information to set the infusion rate. So 250 ml, 25,000 units. Okay. Now I'm running out of paper here, so I'm just going to bring this down here. And after you do that, now a little shortcut. This number, the 250 over 25,000, is the same thing as 1 over 100. Okay, that's just a little tidbit. 9 milliliters per hour is what that would come out to be. So that's what you would program into the infusion pump. You'd give them a bolus dose of 4 milliliters of heparin, and then you would give them a infusion, or set the infusion pump to 9 milliliters per hour. Okay. Now the shorthand for this, like I told you, I had the other, like this one would be 50, the patient's weight, which will always change, right? Times 18 over 100. Okay. So that way, if you're trying this out with a different patient's weight, you can at least get the shorthand answer, and then when you work it out the long way, if you feel like you want to work it out the long way, you can at least compare your answers and have like a shorthand way of doing that. This is what I imagine they use. They will create like an Excel spreadsheet or a program that basically just takes, you just plug in the patient's weight, and then it'll calculate out and it'll give you a running number of how many milliliters to bolus dose for each kilogram weight, down to the 10th, 100th, whatever they decide to go down to. Okay.
That's for answer B, right?
That's for answer B. Yeah. So this first one was A. This is B. You got it. Now for C says we look at the APTT.
I'm sorry. How you get 9 milliliters per hour? Did you change with 250 milliliters dividing by 25,000 units?
Oh, yeah. So all I did was I did 900 times 250.
900. I thought it's 400. I'm sorry. I'm good. Thank you.
Oh, you're welcome. Thanks for asking. Yeah. So I just told you, like, as an aside, 250 over 25,000 is the same thing as 1 over 100. So yeah, that's all. Okay. All right. So for part C1, so just write that over here. For part C1, it says the APTT, 43 seconds. And so I'm going to look at the chart where it talks about APTTs. Step 12 is where 43 seconds falls in. And it says to rebolus with 40 units. Now, 40 units is exactly half of the original bolus, right? So my answer is you're going to give them 2 milliliters, okay? But I'll show you the math, and I want you to do the math because it's good practice, because you might get that as a question. And then it says to increase the rate by 2 units per kilogram per hour. So same patient. Now we're going to rebolus with 40 units per kilogram. And I'm going to get 2,000 units. Okay. I don't want units. I want milliliters. So I'm going to use that. I'm going to go back to my protocol. Remember, my bolus dosage strength is 1,000 units per milliliter. So I'm going to use the same bolus dosage strength number, the 1,000 units, the 1 milliliter, and then you're going to get 2 milliliters as your answer. Okay. So I'm going to circle my answers. That way you guys can see this a little bit clearer. Okay. So 2 milliliters. Now, if you look at the other APTTs, notice that for in step 11, it says rebolus with 80. So you wouldn't have to do anything if you had already solved the initial bolus, you would just rebolus with the same amount, right? So if it was 4 before, it'd be 4 again. None of the other ones have you rebolus. So that's one of the reasons why you most likely will only see step 12, because it has you do both things. Okay. Now, C2 is calculating the change in infusion rate. So it says we're going to increase the rate by 2 units per kilogram per hour. We started at 18 units per kilogram per hour. So 18 plus 2 is 20. So I have 50 kilogram patient times now 20 units kilogram hour. So remember, I'm adding 2 to the 18. That will give me 1,000 units per hour. And then what I'm going to do is I'm just going to bring this down here, the 1,000 units per hour. Now, I don't want units per hour, right? I want milliliters per hour. So I'm going to use going back to my protocol. The main reason I keep going back and forth with this, I just want you to know where I'm getting this information from. So that way you can kind of go along when you're practicing these and be like, oh yeah, this is where we were getting that information from. So notice it says the heparin 25,000 units and 250 milliliters, half normal saline. So that's what I need in order to calculate the IV drip. Bolus dosage strength is what I need to calculate the bolus. So 250 ml, 25,000 units. And then we'll get 10 milliliters per hour. Okay. So for this question, and since we commonly use the step 12 of the protocol, this is going to be 50 times 40 over 1,000. Remember, 50 is the thing that will change because it'll just be dependent on the patient's weight. And then the last one here would be I was hoping that I could do this without folding the paper too much. The last one here would be, again, patient's weight, which will change. So 50 kilograms times 20 divided by 100. And the reason I'm showing you these shorthand ones is just because somebody mentioned it before, and then it might save you some time that I'm showing you that. But I would always double check your answers and then just use this as kind of like a verification that you got it right. So all you're plugging into this like dotted circle here is the patient's weight in kilograms. And that's really the only thing that I'm going to change when when you get the test next week, is just changing the patient's weight. I'll give it to you in pounds, and then you convert it to kilograms, and then go from there.
So other than weight, it's always the same formula, every
Yeah.
other number. Okay.
Yep, you got it. It's always the same. Yeah, there's no variation from the protocol. Yep. Because like I said, if you do a Google search for heparin protocol, you're going to see everything in there is exactly what I wrote up. The only difference is the patient's weight. Are there any other questions?
You said the questions will either be A and B or C1 and C2.
Correct. Yeah, so you'll either get both A and B or both C1 and C2. And for the most part, from what I recall, most people just get the A and the B.
Thank you.
Yeah, you're welcome.
Thank you.
You're welcome.
Thank you.
You're welcome.
There's another one of these on Thursday, just in case we wanted to pop in.
Yeah, and tonight as well. So tonight is I think it's from 6:15 to 7:15 is what I'm remembering. And then tomorrow and then Thursday, there's this time and then the evening time as well.
And just because this test didn't come with it, I just wanted to double check. A teaspoon is 5 milliliters, tablespoon is 15, and an ounce is 30 milliliters.
Correct. Yeah, so if you let me just put this into the chat again. If you go to the OneDrive on the practice tests, I have all those conversions listed on there just if you need a refresher.
Do you know how much rounding there's going to be?
There might be a little bit. Just remember, do not round basic unit, like when you're converting between units, meaning going from milligrams to grams or micrograms to milligrams, milligrams to micrograms, do not round those. But if you're going from pounds to kilograms, round to the nearest tenth. So you might see some rounding, yes.
It's usually just to the nearest 10th. Okay.
Right, yeah, unless it's a number less than 1, then you would round to the nearest hundredths. So like, let's say you had like 0.375, then you would round that to 0.38.
Okay. And you said that's all of that's listed on this link that you posted?
Yeah, there's
like the rounding rules and stuff.
Yeah, the rounding rules are also posted in that area. They're in each of the practice tests. So yeah, they're there.
Okay. Thank you.
You're welcome.